So, deploying RPKI at Hurricane Electric. There. Zoom on. Let me forward the slides now. Okay, so obviously 2020 has been a banner year for lots of things, and it has not lacked in significant developments. But one of the positives was the amount of progress that we made this year in routing security and in general, and RPKI in particular. And what I'm going to talk about today is Hurricane Electric's deployment of RPKI and what's going on with RPKI globally. The supporting tools that Hurricane Electric has to help you in the event of a problem, and a look at RPKI in general and how it's faring. So Hurricane Electric began its RPKI deployment on February 24th when we started filtering our peers and our customers for RPKI invalids, in addition to the normal prefix filtering that we do. And then in May, we started the rollout of a system that finds RPKI invalids that get advertised to us and eliminates those. And by June 16th, we had announced that we had achieved 0 RPKI invalids. Now, we weren't alone in 2020 deploying RPKI, as it turns out. In February, Telia began dropping RPKI invalids as well. And actually, if you look at this chart, there were a lot of other people that progressed along the last 6 months. NTT announced it began dropping RPKI invalids in March. In May, you folks at LINX, GTT, TerraHost, WorldStream deployed RPKI. In June, in addition to Hurricane Electric, Cogent began filtering for invalids. In July, Telstra and then GRIX in Athens deployed RPKI. In August, Google and Hong Kong IX announced their systems. And in September, Swisscom and Netflix were deploying RPKI. So that was significant for a lot of reasons, but the biggest one is that prior to 2020, Tata, PCCW, and AT&T were the big networks that were filtering for RPKI invalids, and they were just doing it on their peers, which left big holes in the global transit network that RPKI invalids could sneak through. With the adoption of RPKI by these 6 transits that I've mentioned, plus the internet exchanges like LINX catching them on the route servers, and then the cloud and content providers like Google and Netflix, taking those out of their network, it has made it a lot harder for an RPKI invalid to get from one end of the internet to the other. So that was different. That was a good, very good progress. So our RPKI system, as has been pointed out in some community discussions, does not rely on routers with the full set of validated row of payloads from an RPKI to router protocol. Instead, what we do is generate our filters for our peers daily, as we always have done, that validate against RPKI and IRR records. And like many ISPs, we have devices deployed at our edge that do not support the RTR protocol. And our system and deployment allowed us to get to 0 RPKI invalids without massive amounts of hardware uplifts. We didn't have to upgrade a lot of software. We didn't have to buy a lot of hardware. We were able to do this without that. And our system will identify an invalid announcement and remove it from the table in less than a minute. So that was a pretty good result. Now, you're probably wondering, what about these filters she's talking about? So what I'm going to do here is take you to routing.he.net, where if you poke on this little algorithm button, you will get exactly how we do our filtering at HE. And I'm going to step you through that. This is what you would see if you popped it up on, maybe not quite as pretty, but this is what you would see if you popped it up on routing.he.net. The first thing we do is we try to find an AS set to use for the network that we're evaluating. And we're going to get that either from the AutNum, or we're going to try to see if we can find it in peeringdb.com. And then after we have that, we collect all the received routes for all of the BGP sessions for this particular ASN. And this will include both the accepted and filtered routes. Next, for each route, we're going to perform the following 6 rejection tests. First, of course, we reject anything that is a default route in IPv4 or v6. And then we reject paths using BGP AS set notation because that's been deprecated. We reject prefix links that are less than the minimum and greater than the maximum. And for IPv4, that means less than a /8 or greater than a /24. And for IPv6, that means less than a /16 or greater than a /48. We reject bogons, RFC 1918, yada, yada, yada. We reject exchange prefixes for all internet exchanges that Hurricane Electric is connected to. And we reject routes that have an RPKI status invalid ASN or invalid link based on the origin and the AS and the prefix that was advertised to us. Then, after you get through all of that, we perform the following 5 acceptance tests. And this will get a little bit into the weeds, bear with me. Number 5 is really long. If the origin is the neighbor AS, the one that we're evaluating, then of course we accept the routes that have RPKI status of valid based on that origin AS and the prefix link. If the prefix is an announced downstream route that is a subnet of an accepted originated prefix that was accepted due to either RPKI or an RIR handle match, we'll accept that prefix. If the RIR handles match for the prefix and the AS and the peer AS, we accept the prefix. If this prefix matches exactly a prefix allowed by the IRR policy of this peer, we accept the prefix. And if the first AS in the path matches the peer and the path is 2 hops long, and the origin AS is in the expanded AS set for the peer AS, and either RPKI status is valid or there is RIR handle match for the origin AS and the prefix, and it's Tuesday, no, I'm kidding about that part, accept the prefix. And then after all of that, we reject all prefixes that are not explicitly accepted. Phew, so we got through that. Okay, so now you're probably wondering, okay, how does all this stuff affect me? And a lot of people wondered that. So if you're wondering, fortunately, we have 2 sets of tools that are already deployed that can help you figure this out. And the first is bgp.he.net, our classic site featuring information about public sources about BGP, from public sources about BGP on the internet. And then routing.he.net, which is that site that has the algorithm, but it also has information on all of the networks that advertise prefixes to Hurricane Electric. And you can see how any of those networks' prefixes are accepted or rejected. So let's go to our friend at bgp.he.net. What I have done is I have popped up AS 44684 here. And full disclosure, the reason why I have done this is because I'm related to Pete Stevens. And if you can't hassle your family, then what fun are they? So we're gonna use Mythic Beasts. And what you can see here is you can choose the tab for v4 prefixes or v6. In this case, I chose v4 because there were more of them. And you can see what the status of each one of those route objects are. So for every route object that has a valid, for every prefix that has a valid IRR route object, you're going to see a bright green checkbox. And you can see that all of Pete's prefixes have bright green checkboxes. And then if they have a ROA, they have a green key. And so all but one of his prefixes has a key. Now, for your network, most of you out there probably know whether or not your prefixes have valid route objects or valid ROAs. And so this might not be so informational for you, for your network in particular, but it is very helpful for your downstreams. You may not have all of those memorized, and it gives you a lot of information about them. So you can take a look and see how things go and see why your routes aren't being advertised. Now, one of the things we noticed with RPKI was people assumed that, that it worked a lot like IRR. And for this particular AS, this is an example of how it didn't. You notice they have lots of nice green checkboxes for all of their route objects, for all of their prefixes in IRR. But they made the mistake of making ROAs for their /22s and then announcing their 24s. And when people started dropping RPKI invalids, they found that their 24s were not being accepted because they were invalid. And the red keys are how we tell that. Each one of those red keys means that there is a ROA for that prefix, but it is invalid. So in this case, it's not invalid due to origin, it's invalid due to length. Now, after this network found this out, they very quickly fixed it. And I had to get this snapshot very fast because I knew they were fixing it, but I wanted it for my slides. But if you looked at it today, you would see that all of their keys are green and everybody's happy. Now, you may not remember seeing these RPKI keys on bgp.he.net before. In reality, we have had them there for 8 years, but because not very many prefixes were in RPKI in the beginning, you might not have noticed them there. Now that more prefixes are coming into RPKI, you're starting to see more keys on bgp.he.net, so it's a little bit more of a common site. So next, if we want to look at what's going on with RPKI, we also have our routing.he.net site. This is the familiar site where we had that algorithm, but also you can enter your AS here and find out why your prefixes are being accepted or rejected. So again, I'm going to take Pete's AS 44684, and if I click the submit button, we get this page. And what this page shows us is the view of AS 44684 from a filtering view at Hurricane Electric. The first box on this page shows the AS set that is being used to generate the filters and how we got it. And in Pete's case, he has the same AS filter for both his IPv4 and IPv6, so that's great. Then if you look at the next table, it's the filters table, and then it shows you which AS set is being used for the IPv4 and the IPv6 filters. And in his case, it's AS Mythics. That's good. That's correct. And then you can see that there are policy, reasons, and filters, which I'll get back to in a second. The next table on the site shows you the prefix lists, and that shows you all of the prefix lists that have been deployed on each router, and what the existing prefix list is, and the log will show you any changes that happened recently. And then all the individual sessions are documented down at the bottom of the page under sessions. It does say that this table is not real time and is delayed approximately 24 hours. Sometimes it's updated a little bit more than that, but it isn't updated as quickly as the other tables. If, for instance, we regenerated these filters for Pete's, for example, the table would update immediately after the regeneration, but the sessions still wouldn't. So let's go back and take a look at those filters. If I want to look at policy, all I have to do is click on display here, and I will get the policy for IPv4. And so here you can see the prefix list for IPv4 and all of the prefixes that are being permitted for AS 44684. So that's pretty straightforward. Now, if I want to know why, notice I've highlighted the reasons tab, the reasons column here. And if you click display where I've highlighted it, you get this. And what this shows you is all of the reasons why each one of these prefixes was accepted or rejected. Now, in Pete's case, all of his prefixes were accepted. And yeah, that's not family favoritism. He just did it right. So, but the first two you can see are accepted because they had an RPKI status of valid. But the third prefix did not have a valid ROA. It had an RPKI status of unknown, and it was accepted because we were able to match the IRR policy on it. So any prefix that you advertise to us will be listed in this report, and you'll be able to see exactly why we accept or reject every prefix you have, and then you can correct your records accordingly. Now, lessons learned, what we learned from our deployment. Well, the first thing we learned was Frank Sinatra is right. We need to do it your way. We rolled our RPKI deployment out in parts, and that worked well for us. And it's the way we do things, and it was successful because we did it our way. And so that would be my advice to anybody else: do it your way. The next thing we learned was that, you know, the whole point of RPKI is it's a routing security protocol, and getting RPKI right is not going to help you if you do not have your IRR filters right. And I'm going to talk more about that in a bit, but it's very important to get those right. And we spent a lot of time getting that right in the filtering part of the deployment. And also that tools give you an advantage. It helped us a lot that we already had bgp.he.net and routing.he.net deployed, because a lot of people had questions. And Hurricane Electric today connects to 8,507 IPv4 networks, and it connects to 5,409 IPv6 networks. That is a lot of people who might have potential confusion, and having those tools in place gave us a big advantage for deploying RPKI. So about RPKI, I thought it'd be kind of interesting to take a look at the current state of it and see where we are. And one of the first things I did was I looked at how many RPKI ROAs we had at the beginning of this whole pandemic in March of 2020. And you can see that we had about 20% of the prefixes in the global table with ROAs, 19% valid, 1% invalid, but 20%. But by September, that had grown by 4% to 24%. And that actually is very significant, because the amount, the rate of increase for 2019 was about, well, this is 150% of that rate. I guess that's the best way to put it, which means that we're growing the RPKI ROAs faster this year than we were last year. And maybe that's a factor that everybody's sitting home having time to get that admin done. I don't know, but it definitely was a step in the right direction. We are creating more ROAs. But what it also tells us is that 76% of the prefixes in our tables do not have RPKI ROAs. So there is a bit of work to be done. Now, to understand where you need to do this work, I have broken down the total amount of space in the IPv4 table by the regional registries, by the RIRs. And when we do that, we can see that 3% of the table comes from AFRINIC, 24% comes from APNIC, 37% comes from ARIN, 10% comes from LACNIC, and 26% comes from RIPE. So then what I did was I broke down those ROAs by region to see what percentage of prefixes in each region had ROAs had created for it. And AFRINIC in March had about 4.6 and went up to 7.5%. So that was a good increase. APNIC went from 17 to 24. ARIN went from 8 to 12. LACNIC went from 30 to about 33. And RIPE went from 34 to 38. Now, RIPE is clearly the winner here, and I don't think it's an accident, because RIPE has done a really phenomenal job of evangelizing ROA creation within its region. And you can see the results have paid off here. You know, they have a large percentage of their prefixes in with ROAs, a much larger percentage than the global table. But if you want to know where the work needs to be done, you need to remember that last slide. Remember, I told you that AFRINIC had 3% of the global prefixes, APNIC had 24%, ARIN had 37%, LACNIC 10, and ARIN 26%. Well, at 37% of the internet, but only 12% of its prefixes in ROAs, where you could really get some traction in getting RPKI deployed would be to make more ROAs inside of ARIN. Clearly, a lot of work needs to be done there if we're going to get the global table with most or all of its prefixes with ROAs. So we got to get busy. Now, RPKI is, you know, a security protocol, and we are interested in being secure. And IR records, unfortunately, are still our last defense. They're the only way to validate origin in 76% of our prefixes, and they're the only way to validate AS path records. So if you're not already doing this, you really should maintain your IR records as accurately as you possibly can. They're very important, and they're the only way that we can make sure that people are advertising the prefixes they're supposed to advertise. Please filter for bogons. Don't advertise them to anybody else. Don't let anybody advertise them to you. And use AS path filters or peer lock against your transit routes so that you are not re-advertising routes that transit providers advertise to you, or that you're not re-advertising those routes that your peers might be leaking to you from their providers. And then announce all of your IP space, because it is really hard for someone to hijack your prefixes if you are already announcing them. Even if you're not using them, the best security practice is to announce your prefixes. And then set prefix limits, because this little configuration saves a lot of headaches in the future. Now, to illustrate what happens when we don't do that, I decided to look at a couple of route leaks and compare the tools we have in our toolbox to dealing with them. And the first one I'm looking at is the Google route leak in 2018. It was the one that affected Google and a number of other services for about 74 minutes. And it happened because a small unfiltered ISP re-advertised 500 Google prefixes that it learned from an IX route server. So what in our toolbox could have prevented this? RPKI ROVs? No, because those prefixes were advertised by Google and were more likely advertised by Google with the correct length. So RPKI ROVs would not have done anything here. Peer lock? No, again, because this was a leak that this ISP had learned from an internet exchange server. It wasn't a bunch of transit routes. So peer lock would not have stopped this problem. IR path filters? You betcha. That definitely would have solved your problem. This ISP was not supposed to advertise these prefixes. And if you're validating path, you would not have accepted the prefixes. Maximum prefix limits? Probably. If you had less than 500 prefixes of wiggle room for this particular peer, then the max prefix limits would have shut that down for you. So let's look at another one. Last year in June, Verizon had an outage that took a lot of the internet down for several hours. And this was a route leak from a small company that was using a route optimizer. And because of that, and it leaked a lot of more specific routes than it learned, making it the preferred path for a large quantity of the internet of routes transiting Verizon. So let's look at that one. Would RPKI ROVs have helped? Well, maybe some of them, because they were changing the path or the prefix length, maybe some of that would have, RPKI ROVs would have helped. But remember, only 24% of the internet has ROVs, and last year it was even less than that, so probably not a lot. Would peer lock have helped? Yes, peer lock would have helped a lot, because this company was re-advertising routes it learned from other transit providers, and peer lock would have shut that down. IR path filters also, yes, in the bonus column, it would have helped because it shouldn't have been advertising these routes. And prefix limits, definitely. This would have shut them down probably before anything else, because it would have exceeded the maximum prefix limits before anything else would have had a chance to be evaluated. So use the tools in your toolbox. So lastly, I'd like you to leave with what could make routing more secure. In today's networks, document the AS paths they're authorized to advertise and to other networks, and you kind of just have to trust them because they can put anything they want in their AS set. A more secure system would have clients identify the providers they wanted to advertise their routes, and this little graph at the bottom kind of shows that, where an AS would give you or would advertise origin validation and path validation, and then the provider could verify that and add its own path validation, since it's going to re-advertise to an ISP, and then the ISP could validate all of that. And if we had a system of validating paths that was a little bit more like that, it might be more secure than what we have today. But the important thing is that this year we did make some progress. We did get RPKI a little bit farther than it was before, and there is a wider net for detecting invalids in our global network. So thank you for your attention today. I really enjoyed being here.